Oh, we're there. Okay, this is a problem. Okay, this is kind of an interesting problem because the actual distances that they give here are pretty darn close. They're pretty darn close. Now, 51 meters is 17 meters. That's around 52 feet. And you might be going, well, wait a minute. Those of you that are baseball aficionados know that the mound, that the pitching rubber is 60 feet 6 inches away from home plate. Yeah, well, by the time those major league pitchers release that ball, most of those guys are kind of tall and lanky anyway, and they are, they're 10 feet away from that rubber by the time that ball is released. So, or at least 6 or 7 feet. So, a major league in excess of 40.1 meters per second. The ball is thrown horizontally at this speed. How far will it drop by the time it reaches the catcher, who is 17 meters from the point of release? Okay? Now, we're not talking about how quickly it's going to hit the ground, right? By the way, we're going to talk about something. We're going to talk about something interesting here too. Before we get started with this, I just thought of this. This is, and I got to make sure I bring this up in class on Thursday. Okay, which I guess is tomorrow. So 41-17. All right, I got it. So we've got a baseball pitcher, and we're just going to draw the baseball. He's launching this thing with an initial velocity in the x direction at 41 meters per second. When we're doing this type of problem, what's the initial velocity in the y direction? Zippity doo-dah. You are correct. So this is problem 29. Okay. Now, discussion. I'm going to take a discussion over here. Throwing the ball, if I throw the ball, neglecting air resistance again, at 41 meters per second, and drop a ball from the same height, which one's going to hit the ground first? Neither. They're going to hit the ground, neglecting air resistance, they're going to hit the ground, hit ground, same time. Okay? They're going to hit the ground at the same time. Reason? The only acceleration that's pulling that thing to the ground is in the y direction. V naught y. In other words, the y component of this and the y component of this are the same thing. Now, if I throw this ball down, it's going to hit it first. If I throw this ball with a speed of 41 meters per second down, of course it's going to hit first because its initial velocity in the y direction is 41 meters per second. Both of them have an initial velocity in the y direction of 0. So therefore, they are both going to hit the ground at the same time. Now, we need to know how far. This problem's actually not too bad. This problem's like, I just now realized this problem's actually kind of easy. Okay. You know why? Because I know that the catcher is 17 meters away in the x direction. So the range, so here we go. Let's set up our x coordinates, our y coordinates, and we'll come back. I don't like for these little things to be longer than 3 or 4 minutes. And I think I've already done that. So we'll come back and set it up, and we'll probably finish it all in about 3 or 4 minutes because this problem's not that bad.